So this equation right here tells us a lot about the vertical position of an object. If you multiply -1/2 times the acceleration due to gravity times t squared, this section of the equation tells you how high the object is as a result of the gravitational force pulling it downwards. And there's a reason for that I'll give you in a different video. If you want to watch it, you can. But this is the vertical component, the part of the height due to gravity. This next part, this is a plus sign, it got kind of obscured here. The next part is showing the vertical height due to the initial speed, because V0 is the initial vertical speed upward. Remember this sub-zero here, this 0, I call it naught, N-A-U-G-H-T, which means nothing, 0. So you might as well just get used to it, but you'll see this in future physics classes. Anyway, V0 is the initial vertical speed upwards, so if it's positive, that means you're going up. Downward would be negative. So down is negative. And so if here it's positive, that's positive. It's going upwards, initial amount of speed. And it would go on forever upwards if it weren't for gravity. So we have to take this into account when we want to find out how high is the object. We have to include that initial vertical speed. And then of course how high is the object, what its vertical position is, will depend on where it started. And that's why not the initial vertical position. So this whole vertical position is a function of time. It will change with time. So let's see how that applies. Oh, yeah, I think I'll skip that for now. There's another useful equation, and that has to do with just simply the vertical speed of the object. And that's where if you look at the acceleration due to gravity and multiply it by the time, you will get the vertical speed. And if you take the acceleration due to gravity, that's meters per second squared, times the time, which is just seconds, you'll see how the seconds and the squared seconds cancel out, and you just are left with meters per second, which is a unit of speed. So speed is acceleration times time. Okay, so those are the equations you're going to need to know, and okay, so this was just an explanation of what I just said. Here's an example. The balloonist descends at a constant rate of 30 meters per second, and they're releasing a weighted marker from the balloon at a certain altitude. So I'm going to draw this picture. So here's the balloon, and that's their basket. And it's already descending at a constant rate. So I know it's going downward at a constant rate of 30 meters per second. That's the given. And it's going to release a weighted marker. So boom, it's going to drop this thing. It's going to go faster and faster downwards. And it's dropping it from an altitude of 200 meters. So this is the starting out initial height. So I could write V0 equals, well, the initial vertical speed was 30 and it's going downwards, so I would say -30 because it's descending, that's downwards, meters per second. Why not, like the initial starting position of the marker was 200 meters. And then what else do we know? Oh, well, of course, acceleration due to gravity is a constant. It's going to be 9.8 meters per second squared. And the question is, how long will it take the marker to hit the ground? So how long will it take is a question of time. So we're going to find time. We're going to solve for t. When there's a certain condition met, the marker hits the ground. So when the marker hits the ground, that's when, well, what's true? When it hits the ground, its height is 0. So when y equals 0. Solve it then.